So our focus today is going to be the Pythagorean theorem. And you may already know the Pythagorean theorem, so that's really good. I learned it back in middle school, and we want to make sure that you continue to use it correctly. So we're just going to do a quick overview of it. But the Pythagorean theorem was discovered or kind of created by Pythagoras long time ago, and it helps us to find missing sides of a right triangle. And that's the first thing that we want to note here, is that it has to be a right triangle. This does not work with acute triangles or obtuse triangles. Has to be a right triangle. So when you're looking at a right triangle, you're typically going to see that little square there in the bottom corner, but it doesn't have to be in that corner. It can look really any way you want it, and as long as you identify the right angle, it can be right up there if we want it to be. So it's going to work in a right triangle. And then the first thing to do now is really make sure we're clear on the different components that make up that right triangle. So the first thing is that every right triangle has two legs, and the legs are the shorter side. So we look at this red triangle, these are my two legs right here. The two legs are those the two sides that really create the right angle. And then this last side of the right triangle is the hypotenuse. And the hypotenuse side, again, it's the longest side, right? It's the longest one. So in this case, it's over here. That's our hypotenuse. And it's located across from the right angle. And so this might seem silly to really focus on it, but identifying what side you're looking at is really important, because students make errors when we do this all the time. So we've got to be very careful to make sure we're looking at the correct sides, and that when we are using the Pythagorean theorem, we're using them in the correct way. So let's jump into a quick example, and if this seems easy, that's great, but let's see how it goes. So again, here's our Pythagorean theorem, and if you want to just highlight or box these two guys up, whatever it might be, these two sides, the A and the B, these are your legs, right? So it doesn't really matter which one you consider A and which one you consider B, but these are the legs of that right triangle. So whichever leg you want to put where, doesn't matter to me, but they have to be those legs. What is most important though is that the C value must be your hypotenuse, right? It must be that hypotenuse. So it's super important that you identify those sides correctly so that you plug them into the right spot on this equation. So A is the first leg, B is the second leg, and C is our hypotenuse. A squared, we square that, plus B squared, we square the B. And when we add those together, we should get whatever the hypotenuse is, C squared. So let's try an example and see how this actually works. So again, here's our right triangle. You'll notice that my right angle is up here. That's important to note. So that means that the 15 and the 36, those are the legs of my right triangle, because those are the sides, the two shorter sides, that are connected to the right angle. So it doesn't honestly matter if you label the 15 as A or if you label the 36 as A, but I'm just going to, for simplicity's sake, go 15 is going to be A and 36 is going to be B. So pretty straightforward. Once we actually set this up, we're going to plug into A squared plus B squared. So we take our A value, 15, and then we square it. I'm just changing colors here. So if we square the 15, we'll figure out what that is in just a second. Then we take our B value, 36, so plus 36, and we square that as well. Okay, oops. So once we square those two, it's going to be equal to whatever the C value is squared. We don't know what that is yet. We could write C, or if you wanted to, you could write X. It really is up to you, since we do have the X down here. But that C is, in a sense, that is our X, right? So if we square these numbers, we're going to end up with 225, okay? 225 plus, if we take 36 and we square 36, that's going to be, this isn't working, 36 times 36 gives me 1,296. And so now this is still equal to, we're still equal to c squared over here. We don't know what that is yet, but if we add those together, we get 1,521. Okay, now we got to be careful because we still don't have our answer. All we know is that when we add those together, we get 1,521. But we now need to figure out what c is, and the only way we do that is by taking the opposite of squared. And the opposite of squaring something is to take the square root of something. Okay, so we practiced this earlier in Unit 3. We looked at square roots, and we talked about how squared and square root. So the opposite of a squared is square root. So we take the square root of the left and the right sides. Notice I didn't do it back up here and I didn't do it back up here. You don't want to do it at these two stages. You have to do it once you have a number all by itself. So 1,521, we take the square root of that. So if we take the square root of 1,521, let me use my calculator here real quick. We're going to end up with we end up with 39. So now we know that this isn't c squared anymore, this is just c. So we actually now know that that is the length of this side of the triangle right here. It is 39 units long. So that's a really basic example of how we use the Pythagorean theorem. We're going to jump in the next video, we're going to look at how we use the Pythagorean theorem to find a missing side that's not the hypotenuse.